Hey everyone, excited to see you here, and I'm excited to give this talk. So today we're talking about building Expo Snack. How many of you know what is Expo Snack? Okay, not that many. Okay, so if you don't know me, my name is Satyajit Sahoo. I'm a core contributor to React Native. You can follow me at Satya164 at Twitter or GitHub. Okay. So if you have ever created a new React Native project or any web project, you know how long it can take. For example, for React Native projects, you do npm install, then you compile it, and then you wait it to run on your device. It takes a long time, and it depends on your internet connection and hardware. It can take up to 15 minutes sometimes. So what if we could we had no setup? Without any setup, what if you could run the app on your device? So if you have ever used some tools like CodePen or JS Fiddle or Code Sandbox, you know that you can start a project on the web without having any setup on your local machine. So Snack is something like that for React Native. You will be able to create an React Native app on the browser and write it in your device without having to do any setup. So this is how it looks right now. We have an editor on the left, and this is a component library. You can drag and drop components into the editor, and you will have all of the code inserted into the editor automatically. For example, if you want to add Facebook login support into your app, you just drag and drop it to the editor, and all the code needed will be inserted automatically. So we'll talk about how it is built and how we built it. So before doing that, let's talk about what we expect from such a tool. So we want no setup. We don't want to do any setup. We just want to go to a link and start coding, right? So then we also want to preview the result instantly without having to do some crazy stuff. Then this is Snack is for mobile apps, right? React Native mobile apps. And you want to feel the apps as you would feel on a real device. You would want to feel the gestures. You will want to see the animations like in a real app, right? And you should be able to debug it. If you want to see a value of a variable, you should be able to log it and see what is there. Otherwise, you'll be stuck. Then it should also be helpful. So we make mistakes. We are programmers. We make a lot of mistakes in code. So there should be tools like ESLint or some static analysis tool which should warn us about errors, right? And then in the end, it should be shareable. You should be able to take the link and share it with a coworker or a friend or or in a blog post or something. And people should be able to go to the link and preview it instantly. So that's our goal is Snack. You should be able to do all of these. So how many of you know AaronPlay? Okay, very few people. So AaronPlay was a very similar project to Snack. It kind of looked like this. We had an editor on the left, and this is a simulator running in Appetize.io. So it was okay, but it was very slow. So how it worked is it had a React Native packager server running in the server. And when you have some code, it will build a full bundle and send it to the simulator. So React Native packager, which is called Metro Bundler now, it's very fast. But when used with this, you have to bundle it, then send it to Appetize. this whole process was very slow. And the online simulator was not very fast either because it is streaming from a remote website. So it was almost unusable. So I have actually never used AaronPlay because I didn't find it fun. It should be fun to try something out, try something new, right? It should not be boring. It shouldn't take a lot of time, right? So that's why we set out to build Snack. It was based on a very simple concept. So how many of you are familiar with hot reload? Like almost everyone, right? So if you used Webpack, what it does, it builds a bundle for the first time, and on subsequent changes, it only sends the new code to the browser. And the new code is executed and displayed instantly without you having to refresh the browser, right? So what if we could do something similar with React Native? What if we just evaled the code, the eval in JavaScript? But eval is evil, right? Yeah, I mean, by using eval, we lose some optimizations from the compiler, but how Webpack does it on the web is it inserts new script tags, and we don't have script tags in React Native. So eval is our only option. Okay. So yeah, so how do we build this with eval? So there are two parts in Snack. One is the code editor, and the other one is the Snack runtime. So the code editor, I showed you the screenshots. And there is the Snack runtime, which is a React Native app running inside Expo. How many of you know Expo? A lot of people. Good. So yeah. So what happens is when you type something in the code editor, it sends the code by a pub/sub library to the app. Then the app evals the code and displays it. We'll see how it is done. So when you change something, it sends new code, and the app evals it again and displays it again. So there are some challenges with this approach. First thing is, in React Native, you are used to write yes next code, right? You use Babel preset stage 3, or you use flow type. And you should be able to write the same code in Snack, but eval won't support that because eval only supports what is supported in the engine. And the engine used in React Native is JavaScript core, and it's a very old version, and it does not support a lot of stuff. So we need to transpile it before evaling. Also, you want to import modules. You want to be able to import various modules in your Snack, right? Because otherwise it will be not very useful. So we need to implement a module system. Then if you ever used hot reload, you might have seen sometimes your app goes into a bad state and it cannot recover until you refresh the page. Maybe you have some error in your render method or somewhere, then you see a red box, and you have to refresh the browser to see the new code. So we want to prevent that. So the first issue is very easily fixable. There is something called Babel standalone, which is a standalone version of Babel. You can run it in Node, in browser, in React Native. You can run it everywhere. We just use it, and this is the API. You just have the standalone.transform. You pass the code, and you pass the presets, and it returns the transpiled code. So the next, so it is easy. The next thing is module support. How many of you are familiar with how Node modules are implemented? Okay. So basically, how it is implemented in Node is, I'll give a rough idea because I'm not familiar with the exact implementation, but it is something like this. When you require something, it is put into a global map, and it has an ID. So when you write require, it looks for that module in the global map and returns it. So we'll do something like that. We have a global object. We have a very snack modules. It's a strange name because we don't want it to collide with anything else. So it's kind of unique name. So we have a global object with a list of modules and their content, whatever they export. And then we pass three things to the function. Require implementation, which is the one passed here. It will get the module from the module map and pass it to the function. The second and third are module and exports. It's basically an empty object. Any module can attach something to the object. So we can get what is exported from your snack. So in your snack, say you can write module.exports equal to something, or export default equal to something, and we should be able to get that. So that's why module and exports implementations are there. So what we do, we take this function and we get the transpiled code, we put it in middle. So this is a string. This whole string is then evaled. Then after it is evaled, we get the default export, and we get the resolve the requires and everything. I'll show you. So yeah, we get the code after wrapping, then we eval it. After evaling, we get the eval value, whatever the value returned by the function. And then we check if it is a ES6 module, because Babel adds this double underscore ES module property to anything that is an ES module. And we get the default export. So yeah, we have the first one is for ES6 modules, the second one is for CommonJS modules. So we get this value, we get the default export from the module. Then the third thing is we need to prevent any errors. We don't want any errors in your render method or any lifecycle methods. So we just patch your component. We just wrap everything in try-catch. So we can catch the errors and handle it ourselves. It is something like this. You just loop over all the things and wrap it in a try-catch. And if we get an error, we just render the error. So yeah, it does not crash React. So this approach has some shortcomings, because we can handle errors which happen in JavaScript, but we cannot handle errors which occur on the native side, because you cannot try-catch them. All APIs in React Native are async, which means they usually return a promise. They don't crash synchronously. If they don't crash synchronously, we cannot do try-catch. So that is one issue. And another issue is sometimes modules in React Native throw a runtime error. For example, you might have faced this. If you put some string inside a view instead of a text tag, your app will crash. Right, so that kind of error we cannot handle. So yeah, these are some shortcomings. Another issue is Redbox and Yellowbox are not available. The reason is when you run the snack app, it is running in production mode, and Redbox and Yellowbox are only available in development mode. So Redbox and Yellowbox are not available in snack. Okay, so this is basically how the module system is implemented, how the code is sent from the editor to the snack, and how it is executed. So yeah, we have a little bit of more code to support things like console log. You can do something like a console log some value, and we'll print it. So we had a custom implementation for console, which gets the values and prints it. Yeah, we have some wrapping, but this is the basic idea. So next thing is you have a snack, and you code in the snack, but now you want to use the NPM libraries. There are a lot of NPM libraries. There are a lot of UI components. There are a lot of utility libraries like Lodash. You want to use them in your snack, right? because you don't want to write everything by hand. Say you have an example on your website. For example, the Apollo website, it uses a snack to give a demo in React Native on their homepage. So they don't want to code everything themselves, right? What if you could just use any UI library from NPM, right? You don't have to write it. So we wanted to add the support for NPM libraries. You should be able to import any NPM library and use it. And we wanted it to be easy to use. We didn't want it to be like complex or time consuming. Right now, to install a library locally, you have to like do yarn add or npm install. Then sometimes you might want to install a specific version. You'll do this. Then you will have a yarn log file. You have to commit this to your repo. Otherwise, sometimes some package will update and it will break your code. We don't want all of that. We want it to be easy. We want it to be deterministic. If you wrote something, it should run forever. It shouldn't break ever. So we wanted that. Also, if we want to support UI libraries, we want to support asset files, right? So, for example, say you use React Native Elements, a UI component library. So it has its own fonts, images. So you should be able to use them. So yeah. So we'll see how it is built. So before that, we should discuss the bundling process in React Native. Basically, there are two types of files. One is code and one is asset. So code is basically any JavaScript code you write. It is just bundled as a string to the bundle, the bundle.js file. But assets are binary files like images or fonts or HTML files. Those files, they are not bundled into the JavaScript bundle. So instead of bundling them, we insert metadata about the asset to the bundle. We'll see how it is done. And the modules, the JavaScript modules are transpiled before bundling. And when you are running the dev server and you change files, it is rebuilt, right? So yeah, that's the basic things about bundling. So this is how an asset is bundled. When you do require some image file, we basically insert this into the bundle. There is an asset registry module, and we call asset registry.register, and we pass some information about the file, like the hash of the file, the dimensions of the file, the name, and what are the scales, because you might have files like at 2x, at 3x, right? We want to pass those information. So we store everything in this file. So this is how assets are bundled, and so the bundler is in React Native is called Metro Bundler. So how Metro Bundler does it? It bundles your code and its dependencies. So and it also includes the information about the assets. So assets are served differently depending on how you are using it. For example, if you are developing, the assets are served from the dev server. But if it is a production app, you are publishing to Play Store or App Store, all these assets are bundled into the package. So, Metro Bundler also includes polyfills and setup code in the bundle. Polyfills as in, because the JSC version in React Native is very old, we need a lot of polyfills to support new ES6 features. So those polyfills are included, and we also have some setup code. The setup code includes setting up global variables needed by React Native, and some polyfills like fetch, XML, HTTP request, all these are implemented. So, but we want to use a bundler in Snack so that we can build the bundles and use them. The problem is we cannot use Metro Bundler in Snack. I'll show why. So the first issue is, what does Metro Bundler do? It bundles your code. It bundles all the dependencies with the code. And it sets up polyfills and an environment setup, right? We don't want that. We want a module, not an app. So the difference is the Snack runtime already includes the polyfills. It already includes the environment setup code. So what we want to include is only the module code. We don't want to include the environment setup. We don't want to include the polyfills. And we also don't want to include a new copy of React or React Native. So we want to be able to exclude those dependencies. And Metro Bundler does not allow us to do that. So we wrote our own. It's called Snackager, Snack plus Packager. So it uses Webpack behind the scenes. How many of you are familiar with Hall? Okay. So Hall is basically a replacement for Metro Bundler. We at Callstack wrote it because we wanted to use the loaders and plugins provided by the Webpack ecosystem. So yeah, we could reuse some code for Hall in Snack. So we use the loader and asset loader and asset plugin from Hall in Snack. And the Snackager then creates a bundle with all its dependencies, but it excludes React Native from the code. It does not include React Native or React. So we exclude some stuff. And it does not include any polyfills or anything. It's basically a server running remotely. You send it a GET request, and it gives you a package. This is how it is. So this is the API bundle / name @version, and then you pass the platforms you want to build for. Then after you do this GET request, it will fetch the metadata about the package from NPM. Then after fetching the metadata, it will check S3 if we already have the bundle, because we upload the bundles to S3 after building them, so we don't have to rebuild the same things again and again, right? So if it exists, it returns it. If it does not exist, it builds a fresh copy. So this is here you can see I'm importing a library, React Native tab view, and it is from NPM. When you write something like this, you write import something from some library, it automatically sends a request to Snackager, and then Snackager will bundle it and return the version number and the bundle and everything. We insert the version number as a comment, so it is there. We know what version you are using, so it never changes. So yeah, you can use this. So it is deterministic. You use a version, it is fixed. And all the dependencies are already included in the bundle, so nothing can break your Snack. So yeah, that's the bundler. The next thing is the editor. So for the editor, we wanted the editing experience to be good. Personally, I use a lot of tools. I use a lot of plugins in my editor. I think everyone uses ESLint and stuff, Prettier, right? So we wanted to integrate those. We also wanted to have a component library like this. You can see how it works. So basically, there is a component library. You search for something, then you drag and drop it. It will insert everything into your render function or wherever needed. See, it inserted the methods required to call the Facebook API, and it also inserted a button into the render. So yeah, that is the component library. We use we do some AST manipulation to insert it into it, but I think that's not relevant. So yeah, so that's it. What are the use cases of Snack? What can you use it for? So first thing is teaching and learning React Native. The good thing about Snack is it does not require any setup. You don't have to do any setup code. So any beginner can start learning immediately. Right? He doesn't have to. They don't have to spend time installing Xcode or Android Studio, or they don't have to learn how Node.js or NPM works. They can just start learning React Native right away, and they can learn the other things during their learning process. So it's very good for teaching. Then prototyping. Personally, I have always used CodePen to like quickly check something on the web. I missed it on React Native because you have to go through all this stuff. So prototyping, I love it. It's a great experience, you'll see. And documentation, you can embed a snack on your website. For example, say you have a library. You can embed a snack on your documentation. So if someone comes looking for something and they have the snack, they can quickly try it out, and they can change some code and quickly see what is happening. So yeah, you can use it for documentation. You can also use it to share any code snippets with friends or coworkers. And you can also use it to report bugs, because usually when you report bugs, you go to GitHub page and then they ask you to provide a repro. Then for the repro, you have to like create a new GitHub repo, set up everything for a simple bug report, right? Here you can just create it on Snack, give them a link, they'll be able to try instantly without having to clone your repo, then doing npm install, all those stuff. So yeah, so this is a screenshot of repl.it. I think some of you might know about it. How many people know about it? Repl.it? Okay. It's basically a website where you can learn different programming languages. They also teach React Native. They have this editor which is based on Snack SDK. Here you can like edit the code on the editor, scan this QR code, and you will have some code running on your phone instantly. We also have a website called Native Directory. It is a curated list of React Native libraries. They have their Snack links. So when you go to Native Directory, you have a link to a Snack, and you can instantly try the library and how it looks, how it feels. So you can make an informed decision if you want to use a library or not. You can also filter the library based on their platform and compatibility with Expo, because Expo only supports JavaScript libraries. This is how it looks. So you have the code examples link there, which is basically linked to a Snack. So what is in the future of Snack? We are working on multi-file support, so you can build full projects on the web without having to do anything locally. And we also want to add support for user accounts, so you can save projects to your user account. So I'm working on it right now. This is how it looks. You have a file tree on the left, and you have the editor. You can create files, folders, organize your things. So yeah. So I just want to say I'm grateful to Expo for letting me work on this. Like it was a very fun thing for me to do. It was a very good learning experience, and I was happy because I felt like I could do something for the community, because this will be useful to people. People will love it. I hope you love it. So yeah, thank you.